By interpreting each as a definite integral, evaluate each of the following limits, which is the first one is limit as n approaches infinity of 1 over n squared plus 2 over n squared plus all the way to n over n squared. So let me write it here. So we are having the first one is limit as n approaches infinity of 1 over n squared then plus 2 over n squared plus all the way to n over n squared. So now you can see that let's factorize 1 over n from this. So this becomes limit as n approaches infinity of 1 over n times. Then this becomes 1 over n plus 2 over n plus all the way to n over n. Now, what does this mean? Remember that we said that the area, which is for the Riemann sums, is limit as n approaches infinity of f of xi then times delta x. But now, what is delta x? You can see that delta x is equal to 1 over n because each of these terms are multiplied by 1 over n. And now, you see that anytime we put 1 over n into x, we are going to get each of this. So you see that anytime we put, so let's assume f of x I is equal to x. You see that when we put 1 over n here, we are going to get the first one to be 1 over n. Then the second one, we are going to put 1 over n plus 1 over n, which is equal to 2 over n. So if we put 2 over n, the second term will become 2 over n, and that is what we have here. And then the third term will be plus 2 over n plus 1 over n, which is 3 over n. So the third term will also be 3 over n. So you see that we'll begin to get all the terms inside the bracket. So that means that f of x, remember that delta x is equal to b minus a over n. So if delta x is equal to 1 over n, it implies that b minus a is equal to 1. So now, if b minus a is 1, the upper limit is 1, and then the lower limit is 0. So this is, we are taking the limit from 0 to 1, because 1 minus 0 is 1 divided by n, so that it will give us back 1 over n. So now, you know that f of x, which is the function, is x, and then delta x is equal to 1 over n, and then the limit is from 0 to 1. So we can transform all of this into an integral. Remember that from Riemann sums, integral of a to b of f of x dx is equal to limit as n approaches infinity of f of xi delta x. So now delta x is 1 over n. So this is equal to integral from the lower limit is 0 and then the upper limit b is 1 of f of x. F of x is x, then dx. So this is, all of this is summed up into this integral. So if you integrate this, you are going to get 1 over 2x squared evaluated as 0 and 1, and this is equal to 1 over 2 times 1 squared minus 0, and that is equal to 1 over 2. So the limit as n approaches infinity of 1 over n squared plus 2 over n squared all the way to n over n squared is 1 over 2. The second one was given as limit as n approaches infinity of n times 1 over n squared plus 1 plus 1 over n squared plus 4 plus up to 1 over 2n squared. So you can see that the changes I happens at the bottom here, which is 1, 4, and then continues. So let's multiply 2 by n. So this is equal to limit as n approaches infinity of n over n squared plus 1 plus n over n squared plus 4, then plus all the way to 1 over 2n squared. So this is equal to, now let's divide both the numerator and the denominator by n squared. So this is equal to limit as n approaches infinity of n over n squared all divided by n squared plus 1 divided by n squared, then plus n over n squared all divided by n squared plus 4 divided by n squared, then plus all the way to 1 over n squared divided by 2n squared divided by n squared. So this will become limit as n approaches infinity of 1 over n divided by, now n squared divided by n squared is 1 plus 1 over n squared, then plus 1 over n divided by 1 plus, now this 1 will become 4 over n squared, then plus all the way to 1 over n squared divided by 2n squared over n squared. So I'll still keep this as 2n squared over n squared. So now this is equal to limit as n approaches infinity. Now we can rewrite this as, let me factorize 1 over n out. If you have factorized 1 over n out, you'll be left with, so let me write this curly bracket well. 1 divided by 1 plus, now I want to write this as 1 over n squared, then plus 1 divided by, I want to write this term 2 as 1 plus 2 over n squared, then plus 1 divided by, I want to write this term 2 as 2 over n squared, sorry, 2 times 1 over n squared, bracket close. So that at the end of the day, you see that I is changing here. So here was 1 plus 1 over n squared, here is 1 plus 2 over n squared, and it is going in that order. So that means that I is here. So at the end of the day, you can see that everything is multiplied by 1 over n, and therefore delta x is equal to 1 over n. So we are taking, if delta x is equal to 1 over n, it implies that b minus a is equal to 1, and therefore a is equal to 0 and b is equal to 1. So we are integrating from 0 to 1, and then delta x is 1 over n, because if we put 1 over n in, successive. But now if we say delta x is 1 over n, what is f of xi? Now f of xi, what function are we going to have said that if we put 1 over n, we begin to get this sort of things? So the function is 1 divided by 1 plus I over n all squared. Now this I is the same as I is 1, 2, 3 continuous to n. Now what it means is that if we put 1 over n, the next term we'll put will be 1 over n plus 1 over n, which will give us 2 over n. And then the next one will be plus 1 over n, which will give us 3 over n, in that fashion. So you can see that the function f of xi is equal to 1 divided by 1 plus x squared. If we put 1 over n in here, we are going to get this first term. And then if we put 2 over n here, we are going to get the second term in that order. So at the end of the day, all of this becomes integral from 0 to 1 of 1 over 1 plus x squared dx, because delta x is 1 over n. Now, How do we integrate this function? You can see that this is a function of the inverse trig functions. If you integrate this, you are going to get tan inverse. This is tan inverse evaluated at tan inverse of x evaluated as 0 and 1. And that will give us tan inverse of 1 minus tan inverse of 0. Tan inverse of 1 is equal to 45. So this is 45. Tan inverse of 0 is 0. So 45 squared units. So that is the answer. Now, I will later do a video on how to do this sort of integrations, integrating the inverse trig functions. Then we will understand why this is tan inverse of x. So the third one was given as limit as n approaches infinity, sum of r equals to 1 to n of 1 over n squared, root square root of n squared minus r squared. So this is equal to limit as n approaches infinity, sum of r equals 1 to n. Now I want to divide through by n squared. So this becomes 1 over square root of n squared divided by n squared minus r squared divided by n squared. So this is equal to limit as n approaches infinity of sum of r equals 1 to n, 1 divided by square root of 1 minus. Now I want to write this as r over n squared. However, sorry, so here is times n, and that will mean that this one is also times 1 over n. So what does that mean? It means that delta x is equal to 1 over n. And if delta x is equal to 1 over n, then b minus a is equal to 1. And therefore, a is equal to 0, and then b is equal to 1. Now, what this means is that if you put in the first one, which is 1 over n, we are going to get the first term here, and then the second term to put 2 over n in that order. So r is the changing value here. So you see that in this case, f of xr is going to be 1 divided by square root of 1 minus x squared. If you put the values of r in this function, you are going to get all the values for this function. So it's equal to. So at the end of the day, then the limit, this limit is equal to integral from 0 to 1 of 1 over square root of 1 minus x squared dx. So we need to integrate this function. How do we do this integration? Let x to be equal to sine u. So dx is equal to cos u du. So now, since we've made x sine u, we need to change this limit to. So if x is equal to 0, then what is sine inverse of 0? Sine inverse of 0 is 0. And if x is equal to 1, what is sine inverse of 1? Sine inverse of 1 is pi over 2. So u is equal to pi over 2. So at the end of the day, this integral becomes integral of 0 to pi over 2. Then dx is cos u du. So that is 1 over square root of 1 minus x squared. X is sine u, so that is sine squared u. Then dx is cos u, so cos u du. So this is equal to integral of 0 to pi over 2. Then it becomes cos u du divided by 1 minus sine squared u is cos squared u. So square root of cos squared u is cos u. So this cos u and cos u cancel out. So this is equal to integral of 0 to pi on 2 of du, which is equal to u evaluated as 0 and pi over 2. and therefore the answer is equal to pi over 2. So limit as n approaches infinity, sum of I equals 1 to n of 1 over square root of n squared minus r is equal to pi over 2.